Good morning, students. In last class, we have discussed regarding 8051 Assembly Language Programming. Today, we will be moving ahead with the next chapter, which is chapter number 3, and it is related to 8051 Addressing Modes. Till now, we have seen the instruction set and the format how to write an assembly language program. Now we will be seeing the addressing modes which are available in 8051 microcontroller. Basically, what is an addressing mode? Addressing mode is a way or a procedure to address or to call any operand. Addressing mode is a way to call or to address any operand. Operand is simply the operator registers or the operation data which you are including with the mnemonics. In other words, various ways to access data are called addressing modes. The ways or the method by which we access our data is called addressing modes. Operand here means the data which we are operating upon. For example, add R1, R2. Then R1 and R2 register are your operands. And add is the operation which we are going to perform on R1 and R2 register. So R1 and R2 are the operands. It can be directly addressed from memory or by register name, or it can be a numerical data. Operand can be a direct address or register name or some number format data. It is not specific that operand can be any register only. It can be a direct address of memory, it can be register name, or it can be numerical data. For example, add R1, R2. Then operand is in terms of register name. Move a comma hash 55h. Hash 55 means it is in form of numerical data. Then move a comma 40h. 40h is the direct address because here hash is not mentioned before the number. So whatever data will be saved at 40h address, that data will be moved to a accumulator register. So your operand can be in form of direct address, register name, or numerical data. Operand is the data on which we are performing operation. In 8051 microcontroller, there are 5 types of addressing modes. First type is immediate addressing mode. Second type is register addressing mode. Third type is direct addressing mode. Fourth type is register indirect addressing mode. And fifth type is index addressing mode. These are the 5 types of addressing mode which we will be seeing in the upcoming slides. So first one is the immediate and register addressing mode. If the operand is a constant or it is in form of some number, then it can be directly stored into memory immediately after the opcode. After the opcode means once the instruction has been executed, then the data can be immediately transferred to the memory. For example, here in the last line, the instruction given to us is move R0, hash 34. So hash 34 is the number data. See, keep one thing in mind. Whenever there is some data written after hash symbol, then we will treat it as numerical data. And if it was written move R0, 34 only without any hash, then that will be treated as a direct address of memory. From that address you have to fetch the data into R0. So at that time 34 will be treated as an address of memory. Now whatever data present at that address, you have to fetch that data to R0 once move instruction is executed. But here the instruction given to us is move R0, hash 34. So hash 34 is the direct or the immediate data given to us which should be transferred to R0 once this move instruction is executed. So here this is example of immediate addressing mode. Directly data given to you in instruction only that you have to simply or immediately transfer to the register. So this is immediate addressing mode. Immediate addressing is only of use when the data to be read is a constant. If instead of hash 34 only 34, or instead of that R1 register was given, then at that time we have to look what is the data saved at 34 address or at R1 register. We have to first fetch that and then we have to transfer it to R0. So it will become a two-step process. But here directly data has been given to you is 34. So we have to simply move it to R0 register once this instruction is executed. So this is an example of immediate addressing mode. Whenever the data given to you is directly in form of some constant and you have to perform operation on that, then it is the example of immediate addressing mode. If the program needed to perform some calculation based on the number of weeks in the year, you could use immediate addressing to load the number 52 into register and then perform arithmetic operation upon this data. This is another example of immediate addressing mode. The above instruction which we saw was an example of immediate addressing. Whatever I said or whatever I discussed in the previous slide has been written here for your knowledge. You can understand it slowly. If you are not able to get it, whatever I discussed in the previous slide, the same thing has been discussed in this slide. The previous example was example of immediate addressing mode. Whatever the register given to you is R0. The data 34H will be moved to R0. The assembler must be able to tell the difference between an address and a piece of data. So that's why we are using symbol hash. Hash symbol is used for this purpose only. Whenever the assembler sees hash symbol before a number, it knows that it is an immediate addressing mode data. So this I have already discussed in the previous slide that hash, after the hash, whatever data given to you is directly treated as a data, and if hash symbol is not there, then it will be treated as an address. Now the next mode is register addressing mode. We have moved our data from one register to another register for any operation, then it is an example of register addressing mode. Here the example given to us is move A, R5. So from one register to another register we are moving the data. So it is an example of register addressing mode. Same way, the second example is add A, R6. So here we are performing addition of data between the two register set. whatever data present in register A and register R6 will be added after this instruction. So again, we are using two register to perform our operation. So again, this is an example of register addressing mode. Wherever we are just using register to perform any operation or any task, then it is an example of register addressing mode. We are moving our data from a register into accumulator, or we are performing any arithmetic operation on it. So this is an example of register addressing mode. Now the third mode is direct addressing mode. Now if you want to transfer a data directly from some memory location into register, then we will use direct addressing mode. Direct addressing mode is used for accessing the data from the on-chip RAM memory location. Some location will be given to you in instruction. From that location you have to fetch the data, and on that data you will perform the operation given in the instruction. For example, here move R0, 40H is given. So 40H is your location. Whatever data given in 40H, it will be moved to R0 register once this instruction is executed. Again, the next instruction is move 56H, A. Now, you have to transfer the data of accumulator register to 56H address or 56H location. Let's take an example. If the content present in A register is 10, A is equal to 10 is the data given to you. After executing move 56H, A instruction, now your location 56H will have data 10. Whatever data present in accumulator will be transferred to location 56H. So this is direct addressing mode. Whenever we are directly transferring the data from some memory location or to some memory location, then it is called direct addressing mode. Few more examples are given here in terms of move instruction. The role of direct addressing mode is the same only whenever we want to transfer any data from one memory location to another register, or from one register to any specific memory location, then that type of instructions are included in direct addressing mode. Directly address is specified in the instruction from where you have to perform the fetching of your data. So this is called direct addressing mode. The next type or the fourth type of addressing mode is register indirect addressing mode. Register addressing and direct addressing, both the modes restrict the program to perform any manipulation of data in fixed addresses. So that's why to combine the features of direct addressing and register addressing mode, we have a newer type of addressing mode which we call register indirect addressing mode. So the example will be given in the next slide. The address of the instruction move A, 30H cannot be altered while the program is running. So at many times we need to transfer, or we need to change memory location for reading and writing the number of locations. So at that time we are using register indirect addressing mode. Let's take an example here. If you have an array of 8-bit number stored in memory starting from 30H memory location, and you want to examine the content of each number in the array, then we will start reading from location 30H, then 31H, then 32H, and so on. So this is an example of register indirect addressing mode. The format of using register indirect addressing mode is given to you. Move a comma at the rate RI. RI can be either R0 register or R1 register. So this will be used as pointer registers. Again, the example given to you is move a comma at the rate R0. So now just see what is the difference between the first instruction and second instruction given to you. In first instruction, we have written move R0 comma hash 30H, while in the next instruction we have written move a comma at the rate R0. In the first instruction, it is an example of immediate addressing whereby the data 30H is placed in R0 register. The second instruction is indirect addressing mode. It moves the content of location 30H into accumulator. So this is the difference between two registers or two instructions. Now, if we want to get the data from location 31H, then we can use a following set of instruction, which is increment R0, and at every time from the newer location we will start transferring the data to accumulator. So it will just act like pointers in C programming. Every time from newer location a value will be loaded. Let's take an example. If R0 is currently at 10H, increment R0 will increment the data from 10 to 11H. Now, whatever the data saved at 11H will be moved to accumulator when second instruction is executed. Once this is over, again incrementing R0. So from 1 to H or 12H, again data will be transferred to accumulator. So every time from all locations we can fetch the data using this set of instruction. So this is called register indirect addressing mode. Now the fifth type of addressing mode is index addressing mode. Index addressing mode is widely used in accessing the data elements of lookup table entries which are located in the program ROM memory space. Here the instruction given to you is movc a comma at the rate a plus dptr. dptr is the data pointer register. It is a 16-bit register while accumulator is an 8-bit register. So the 16-bit register DPTR and register A are used to perform the address of data element stored in on-chip ROM. Because the data elements are stored in program or code memory, index addressing mode is used. Here, instead of writing movc, we are directly using, instead of writing move, we are directly using movc. So C stands for code memory. Here data will be directly moved to code memory. So this is an example of index addressing mode. So Here we are completing the 5 different types of addressing mode. Please refer to it, and once it is clear to you, you have to perform this task. Your today's task after watching this video is to write an assembly program for moving the data starting from memory location 40H to 44H into accumulator, and you are not going to use any kind of jump or loop instruction. Only using the different types of addressing mode you are going to write the assembly program for this question. So do complete this task, and if you have any query you can ask me. We have started with chapter number 3, and in that we have started with first topic, which is 8051 addressing mode. In next session we will discuss the next topic. Up till now, please finish or revise the different types of addressing mode of 8051. Thank you.